Here was our long division for numbers. Again, you always looked at the first set of numbers until you could say I could divide 13 into 27 2 times. Whatever number you had, you then multiplied it by the 13, subtracted, and kept the process going over and over and over again. At the bottom of the page, we're now going to see what this looks like with algebra. If you have 3x squared minus 4x plus 5 and you want to divide by x minus 2, what would you get? What would this look like? Well, if I set it up the same way as we did long division with numbers, I would have 3x squared minus 4x plus 5. And I'm dividing by x minus 2, so I put the x minus 2 out in front. And just like long division with numbers, you look at the very first thing you have. I have a 3x squared. Is there something I could multiply this x by to get 3x squared? What would you have to multiply x by to get 3x squared?
3x.
3x. So then above my x's, I write 3x. So in the same way in long division, you put the number over a certain hundreds, tens, or you sort of do the same thing here. I'll put it above the x's. And then what did I do with my numbers? I took whatever number and multiplied it by the 13. But now I'm going to take the 3x and multiply it by this whole thing. Well, 3x times x, of course, is 3x squared. And 3x times the minus 2 is minus 6x. In long division, the next thing you did was subtract. So we're going to subtract as well, but we're going to make sure we put this in brackets because you're subtracting all of this. And the nice thing that happens is 3x squared minus 3x squared is going to be 0. But then I have a minus 4x minus a negative 6x. That's going to be plus 2x. And the 5 can just be brought down. Just like we brought a number down the last time. Now my new number is 2x plus 5. I'm going to change colors. I'm going to change to purple. My new number is a 2x plus 5. What would you have to multiply x by to get a 2x? 2. So above here we'll write a plus, because it's a positive 2. We'll write a plus 2. Same process. That new 2, you multiply by the x, you get 2x. You multiply the 2 by the negative 2, you get negative 4. You put it in brackets and you subtract. Obviously 2x minus 2x would go away. What is 5 minus a negative 4? And that's your remainder. What does this mean? This means that 3x squared minus 4x plus 5 is equal to x minus 2 times 3x plus 2, but it doesn't quite work. That's the closest you can get. But you're off by 9, so we have a remainder of 9. You still need to add 9 to make it work. If you multiply this out, check it out. Do you see that you would get the 3x squared? Do you see that your outside 2x and inside minus 6x would give you minus 4x? But when I do negative 2 times 2, I get minus 4. And I was supposed to get plus 5. So I have to add 9 to make it work. It doesn't work out perfectly. The second one. This time we have a cubed. X plus 1 divided by 2x cubed minus x squared minus 2x plus 1. First thing is a 2x cubed. And the nice thing about long division is if you get the first way of doing it, you just repeat the same thing over and over again. It's the same steps every single time. What would I have to multiply x by to get 2x cubed? $2x squared? Yeah. So I'm going to, above my x squared, I'm going to write that 2x squared. And sure enough, if I multiply and distribute, 2x squared times x is 2x cubed. And 2x squared times 1 is plus 2x squared. Put it in brackets and subtract. First ones should always go away. Minus x squared minus 2x squared will be minus 3x squared. And then I still have minus 2x and I still have plus 1. Those ones you can just bring down because you're not subtracting anything underneath those ones. Switch colors. I did purple next. Now I have a minus 3x squared. What would I have to multiply that x by to get a minus 3x squared?
Minus 3x.
A minus 3x. I write that above the x's. Minus 3x times this minus 3x squared. Minus 3x times the plus 1 minus 3x. Put it in brackets and subtract. Well, that goes away. Minus 2 minus the negative is adding. That's going to just be x. And bring down the 1 plus 1. Switch colors one more time. Now I have an x. What would you have to multiply x by to get x? 1. So I write plus 1. 1 times x is x. 1 times 1 is 1. And when I subtract now, I get 0. And you have now done something for the first time that you've never done before. Okay? And I'll show you what you just did. If I write out what this answer means, you took 2x cubed minus x squared minus 2x plus 1 and got x plus 1. This means that 2x cubed minus x squared minus 2x plus 1 is equal to x plus 1 times 2x squared minus 3x plus 1. Do you know what you just did, or what we just did for the first time ever? You factored your first cubic. Up till now, we were factoring quadratics, right? We're going to find out you can now factor stuff like this. And it's going to involve long division. But it only works if there's no remainder. Like the first one, it didn't work out perfectly. It had a remainder of 9. This one was beautiful because it has a remainder of 0. And if it has a remainder of 0, you have factored it. Of course, there's still some missing pieces. Like, how did you know to choose x plus 1? Right? They gave us that, and it happened to work out. We're going to figure out all of those pieces, but you're going to have to factor things now that go beyond x squared. In fact, once you factored this one, if this said factor completely, well, the rest of this, if it could factor, it would have to be 2x and x. It would have to be 1 and 1, outside and inside, to make negative 3. There it is, factored completely. And we're going to find out that if you can factor this completely, you can draw this graph really easily. And that's our whole unit. We're done. Well, no, we have to get a few more details. But that's what we're going to look at in this unit. We are going to use long division as a technique to be able to factor. And if we can factor those, you now can solve much more difficult equations than you used to. And if you can factor and you have an equation, you can now graph these. So we're going to look at graphing and solving and factoring in this unit. Let's just start off with we are, just practicing our long division techniques. And for our long division techniques, there are a couple of protocols that we have to follow. So we will start with those protocols. And one of the protocols comes into effect here. I'll call it the setup. First thing in our setup, when we're doing long division, you must write the polynomial in the right order. So, you see how I have the 2x cubed? What probably should come next instead of the 3x squared? So, setup, we're going to write the polynomial in descending order by degree. So degree, that's a grade 9 topic. The degree of x cubed is the exponent. Its degree is 3. The degree of the 3x squared would be 2. So you start with your biggest one and write it down in descending order. And if a degree is missing, we have to add a 0 as a placeholder. These things never came up in numbers. When you do long division with numbers, you never have to worry about order. Because in numbers, when you write this number, everybody knows the 7 stands for 7 hundredths. Everybody knows the 3 stands for 3 tenths. And the 1 stands for 1 1. Right? But in polynomials, you could rearrange this in a whole bunch of different ways and it would still make sense. So for long division, we want to write things in the right order. That's going to be very important. Right? And in numbers, when there's something missing, we write a 0. You have 7 $100 bills, 0 $10 bills, and 5 loonies. In total, you would have $705. That 0 is important. You can't just not write it. Oh yeah, you have $705. I just don't write zeros. You'd be like, wait a minute, that looks totally different. The 0 is important when we write numbers, okay? But in polynomials, if you have no x squareds, you just don't write it. So we're going to have to add a 0. So we're going to see in our next couple examples what this means. In this first one, so here's our setup. I'm going to just make it a little smaller. We can make it bigger again if we want to see it. Just get it out of the way. But for our setup, we're dividing by x minus 1. And for our setup, the first thing we have to make sure we write this in the right order. There we go. So the 2x cubed is first, the 3x squared is next, then the 2x, then the 5. That is in descending order. What would you have to multiply x by to get a 2x cubed? In fact, I'd encourage you to get started ahead of me and see if you can finish without making any mental math mistakes before I do. So we've seen the technique already. What would you have to multiply x by to get 2x cubed? You'd have to multiply by 2x squared. And so I write this above my x squared. And then I multiply 2x squared times x, 2x cubed, and subtract 2x squared. Put that in brackets and subtract. If you're going to make a mistake in long division, it's usually an adding and subtracting mistake. Be careful with your mental math. So only look up if you want to check if you're going right along the way. So there's a remainder, which means that 2x cubed plus 3x squared minus 2x plus 5 does not perfectly divide by x minus 1. The closest you can get, so if I rewrite what this statement means, the closest that we can get is that 2x cubed plus 3x squared minus 2x plus 5 is equal to x minus 1 multiplied by 2x squared plus 5x plus 3. If you multiplied those two out, like all the arrows you'd have to do to multiply that out, you would get perfectly 2x cubed, you'd get perfectly plus 3x squared, you'd get perfectly minus 2x, but you would be off on the last number. In fact, you see the last numbers here, minus 1 times 3, you'll get minus 3. You're off by 8, so we have to add the remainder of 8 to make it work. And this is the same thing that's true with regular numbers, right? If I took something like 59 divided by 7, that doesn't work out perfectly. That's not on your times table. What's the closest that you could get to 59 on your times table? Ooh, testing your times table this early in the morning, eh?
What's the question?
What's the closest you could get?
56.
56, which is 7 times 8. So would you agree this is 8, but there would be a remainder of 3? Right? A couple of things mathematically. So this means that 59 is equal to 7 times 8. That's not quite close enough. You have a remainder of 3 plus 3. It also means that if I wrote it out originally like this, 59 divided by 7, it's equal to 8, and the remainder of 3 still needs to be divided by 7 to get a decimal. So if you're good at your decimals, right, I think I showed you that the 7s were my favorite numbers, so this is equal to 8.42857 repeated. If you know your fractions to decimals, then you can write out the exact answer quickly. But we can use this process in numbers, we can use it in algebra as well. Okay, the ones you can circle for question 1 are 3, A, C, D. And 5.